Hi, this is Dr. Hubbard here with a few introductory problems involving functions. We're calling this part 1. And I'll just give you a few examples and then you'll have a few problems to just practice to get comfortable with some things. So first, define function f from r cross r, we call that the Cartesian product or the ordered pair, to r, these are the real numbers, right? By f of xy equals the absolute value of x plus y squared plus 1. Now, if you're ever wondering sort of what elements of this look like, you can always sort of look to the definition. Oh, it's just an ordered pair, so two real numbers. State the domain and codomain, find the range of f, and justify your answers. Okay, so let's see, the domain. The domain is fairly straightforward if a function is stated this way. The domain is just the list of possible inputs. So it's going to be the reals cross the reals. The codomain also is pretty straightforward. That's why it doesn't say find them, it just says state them. The codomain is sort of the list of possible targets. It's not the targets you actually hit. Remember, it's the list of possible targets. The range, if you recall, the range is the list of elements of the codomain that actually get hit. So we'll say the range of f xy, so take everything in the domain, run it through the function. Those are going to be real numbers, okay? And let's sort of see the things that get hit. Will you hit every real number? Will that happen? Well, let's see. Now I'm going to use the definition of the function. F of xy is absolute value of x plus y squared plus 1 for any real number x and any real number y, right? Just using that definition. Now I have to think about this, okay? What is this? Well, the absolute value of any real number is a non-negative real number, right? The square of a real number, you can square any real number, you'll never get a negative real number, but you can get any positive real number and you can get 0. And if you're adding 1, so this can get you any real number greater than or equal to 0, any real number greater than or equal to 0, and add 1 to it. So combining these, you can really get any real number z that is greater than or equal to 1. And one way to notate that is z greater than or equal to 1 for any real number. So that's one way to describe the range. There are other correct notations, but we'll stick with that. Second, define G from 2 by 2 matrices with elements in the integers. This blackboard bold Z is the integers. Again, you can see what that looks like by looking at that element. 2 by 2 matrices have 2 across, 2 down, 4 entries, and they're all integers. Mapping to the reals cross the reals, where the first entry is A plus D over 2, and the second entry is B. State the domain and codomain, find the range of f, and justify your answers. So, domain. Well, that is simply 2 by 2 matrices with entries in Z. The codomain, again, this is really mainly about spotting it when you're using this notation. The codomain, the list of possible things in the target, is the reals cross the reals. The range is a little more work, okay? And notice that it's important to notice the range is always a subset of the codomain, and it could be the whole thing, but often it's not. So the range, that's the set of G of A, B, C, D. So anything you could hit such that A, B, C, and D are in fact real numbers. This is integers. Integers. Yes, we don't have anything that's not an integer here. Okay, so let's think about that. What is this? That's going to be an ordered pair. The first number is going to be A plus D over 2. The second number is just going to be b. Notice c doesn't do anything. No, it doesn't matter really what c is. So I'm actually going to drop it entirely here. And then clearly this can be any integer. I'm going to go ahead and leave the b there. You can see, hey, if b can be any integer, it's just any integer. But if you add a plus d, think about that. You add any integer plus any integer, you really just get an integer over 2 for any x and b integers. So that's a pair, but it's not any real numbers. It's any real number, any integer divided by 2. So you can have 3.5 or negative 3.5 and any integer. So again, a subset there. That'll always be the case. Finally, let f and g be defined as above. Does the composition f of g make sense? So let's think about that. F goes from reals cross reals to the reals, right? And where am I going to put g? You're actually going to put g to the left. G needs to have its outputs being the inputs there. So this does make sense. And this little chart is also going to help. Yes, f of g makes sense, right? Well, what's the domain? What's the list of possible inputs for this function? Well, you're going to start with 2 by 2 matrices. Your codomain, what kind of things could you possibly come out with? It's just going to be a real number. In between, you'll have Cartesian pairs. A Cartesian product is your set, I should say. So what is my range? Well, my range, of course, is the very definition of composition of functions. Remember, what is a composition of function? F composed with g. Well, it's f of g of whatever the input for g is. The input for g is a matrix, A, B, C, D, right? Such that, well, we have to start out with A, B, C, and D. They're integers by the definition of the domain of g. What does g do to that? Well, by definition, g takes that to A plus D over 2 B. And we thought about this in the last problem, but A plus D, when we're talking about sets, right, this means the set of all things of this form, we could just call that x over 2. It's not integers, but it's half integers, such that x and b are integers, okay? And then what happens if we take that to f of x? Remember, the definition of f was absolute value of the first thing. So we're going to take the absolute value of x over 2. That means we'll get a half integer, but it can't be negative, plus b squared plus 1, such that x and b are integers. So what does this actually give me? This is a half integer that's non-negative. So it gave me a half, 1, 1.5, 2, 2.5 on up. This is going to give me the square of an integer, could give me 0, 1, 4, 9. This is just going to give me 1. Notice nothing can get less than 0 plus 0 plus 1. So we're going to get something that's greater or equal to 1. And notice this is y over 2, where y can be any integer. But we can't go less than 1. Hope that's helpful.